Welcome to Emtron Training Part 33. In this training tutorial, we're going to be taking a look at working with our Transient Spark programming. Our Transient Spark allows us to either retard the spark when we're having a positive rate of change in our throttle movement, or advance the spark when we're decelerating and actually closing our throttle. We're going to be talking about and focusing on our Transient Spark when we're actually opening the throttle to be able to have a dampening effect if we have an extremely large throttle body to improve drivability, or if we're experiencing tip-in knock conditions where we're having rapid changes in throttle and we're seeing that we're constantly generating knock, we can take care of it within the Transient Spark. So we're going to go through how it works, how to calibrate and tune with it. We have lots of things to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our Transient Spark tuning in our Emtron ECU. Our Transient Spark will allow us to retard the spark timing when we're having a throttle input or a throttle movement as we're driving our vehicle. A similar idea we've talked about with our transient fuel, where we had different rates of changes in our throttle movement. A very large rate of change could equal a very large rate or burst of airflow entering our engine. To be able to compensate for this, we use the transient fuel to increase our injector pulse width very briefly in order to combat that burst of airflow so the engine doesn't lean out and it drives smooth. The same kind of concept here is going to apply to our spark timing. So as we're having a large rate of change in our throttle movement, we might find the need to retard our spark timing. And that might be a result of trying to improve drivability. You might find it dampens out some of the jitteriness of driving on let's say a relatively large throttle body, for example. Or we might have an application that it's going to have a small turbocharger or a roots or positive displacement style supercharger, where we have a very unlinear relationship between our throttle movement and our boost pressure. If we find that if we give a little bit of a throttle input and all of a sudden we have a rapid change in manifold pressure, we might have to retard the timing, because with the manifold pressure is jumping a huge amount, that's going to have a huge jump in cylinder pressure, and as a result we might have something called tip and knock. We want to avoid tip and knock. The way to do that is using a transient spark type of compensation. Let's go and take a look at where we can enable our transient spark and then how to work with it. It's actually relatively simple, but there are some rules of thumb that we need to keep in mind. So what we're going to do here is jump into our ignition area, come down here under transient, and then in here we have our transient setup. This is where we actually turn on the actual feature to work and some other parameters that we need to program. And then down here at the bottom, we'll find this is the ignition advance rate table and ignition retard rate table. Let's talk about these first, because these are in place and applied regardless if we're using transient spark compensation or not. Let's take a look at our advance rate table. This is going to be specifying how many degrees per second we're allowed to move if our spark timing advance changes, let's say from our main spark timing table. So if we're going from, let's say, 20 degrees to 30 degrees, how quickly that change can happen. Again, this is degrees per second. If we're looking at here of a value of 3,000, this is essentially going to make an instantaneous change when the spark timing is commanded to move from one timing value in advance to another. We can see this table here is built on our ignition table 1 spark timing commanded values 0 to 50. These are in degrees. And then at the top, that's going to be engine speed. So when we're taking a look here, 30 degrees and less, anytime we're having an advanced value go from, let's say, 10 degrees to 20 degrees or 20 degrees to 30 degrees, it's essentially going to make that change happen instantaneously, advancing the timing. If we're moving up here to the higher advance amounts, depending on where we're at with engine speed, that transition from going from one spark timing and advancing it to another value, that'll happen a little bit slower. So if we're finding here, this is 7 degrees, so 7 degrees per second is what this specific rate table is going to allow a change to happen in. That's going to be at a 50 degree commanded value at 6,000 RPM. Well, in this situation, we have a very high spark advance amount and a very high engine speed. The likelihood of us having to move or advance the timing very quickly is probably going to be non-existent. But if we do, we want to be slower of how we're actually applying that. So we can see how this table is set up. We typically don't need to touch this table at all, but it is active and it is good to understand what its purpose is going to do. Jumping back in here, we also have a retard table. So our ignition retard rate. This is how quickly timing is allowed to be pulled out. Now, traditionally, we want to have this table maxed out. There's really no reason to go in here and have our table anything other than 3,000 degrees per second of change. This is especially important if we're working with something like... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.